Okay, this is a video showing an example of parameter variation. I didn't erase the formulas because we are going to use it, and this is the problem. So second derivative plus 3 first derivative plus 2y equal to 1 over 1 plus exponential of x. Now, this I cannot solve it with the with the undetermined coefficients. Okay, so we have to use this method. Now, I didn't mention in the last video, but the method of the particular solution using parameter variation, which propose the particular solution like this: w1 of x y1 plus w2 of x y2, works with anything that you have here as q of x. Anything. So it works with sine, cosine, polynomials, whatever. Alright? The previous method only works with sine, cosine, exponentials, and polynomial. But this method works for everything, whatever you have in the q of x. Okay? Just make sure that you have the first coefficient is 1. So we have the 1, so that is no problem. So the first step is actually to find y1 and y2. The y1 and the y2, they are solutions of the homogeneous. So let's find the homogeneous solution. So the differential equation homogeneous is second derivative plus 3 first derivative plus 2y equal to 0. The characteristic equation is m squared plus 3m plus 2 equal to 0. Now, two numbers in which the multiplication is 2 and the addition is 3, so it's very clear, m plus 1 and m plus 2. Alright? Yeah. Okay, so my first root is minus 1 and my second root is minus 2. So the first solution is exponential minus x and the second solution is exponential minus 2x. Alright? I can write here what is the homogeneous solution, or we can write it at the end, but let's write it. C1 exponential of minus x plus C2 exponential minus 2x. Okay, now this y1 and this y2, we are going to use it here to find w1 and w2. So the particular solution is now this. We have y1, we already know it, it is here. The y2, we know it, it is here. What we don't know is w1 of x and w2 of x. And they are calculated using these formulas. Okay? So let's do it. The first thing to do is to calculate the determinants. Okay, so let's calculate the determinant delta. So delta is equal to the first solution y1 exponential minus x, and the second solution is exponential minus 2x. Now in the second row is the derivative, minus exponential minus x, and derivative of this minus 2 exponential minus 2x. Okay, so this times this, minus 2 exponential minus 3x, because you multiply this and this, so the power adds together. Minus 1 and minus 2 is minus 3, and then minus, because you have a minus here, then becomes positive, exponential of minus 3x. So the result of this is minus 2 plus 1 minus exponential minus 3x. Alright, so we calculated this delta. Now let's calculate delta 1. Delta 1 is going to be the determinant of 0 and q of x. 0 and this q of x, 1 over 1 plus exponential of x. And then y2 and the y prime 2. So it's going to be exponential minus 2x and minus 2 exponential minus 2x. Okay, now because this is 0, the only thing that is left is this one. So it's going to be minus exponential minus 2x divided by 1 plus exponential of x. Okay, so that is the result of delta 1. Okay, now delta 2 here, I'm going to calculate delta 2 here, is going to be, so now it's going to be delta 2 is y1 and y1 prime, so this same determinant, so it's going to be just exponential minus x and minus exponential minus x. And then 0 here, and q of x, 0 and q of x, 1 over 1 plus exponential of x. So this is going to be this times this is the only thing, because this is going to be 0. So I only write this part. Exponential minus x over 1 plus exponential of x. Okay, so that is delta 2. Now, let's calculate w1 of x and w2 of x. So, the formula is just w1 of x is going to be the integral of delta 1 over delta. Delta 1 is, I'm going to need bigger integral. So it's going to be minus exponential minus 2x divided by 1 plus exponential of x. And then divided by delta minus exponential of minus 3x. I'm going to add 1 here to make the sandwich rule. Okay? And then we are going to use the W2. I'm going to need to erase this part because I'm going to need it for the formulas, alright? To continue the problem. Okay, so if we use the sandwich rule here, so we are going to get the integral of minus and minus cancels, so this times this, so it's going to be exponential of minus 3x divided by the exponential of minus 3x is going to be just the exponential of x here over 1 plus exponential of x differential of x, okay? Because this is going to be in the denominator, so it is negative. If we pass it to the numerator, it's going to be 3x. 3x minus 2x is just 1x, right? Okay, now this is a very easy integral because we are going to use the formula 1 over u differential of u, where this is u, 1 plus exponential of x, and differential of u is exponential of x differential of x, which is here, alright? Okay, so this is just simple. This is just simple, the natural lorem of 1 plus exponential of x, and that's it, okay? Don't confuse with this part. This is something different. So we have w1 of x. Now, w2 of x is going to be w2 of x is going to be a big integral. So now it's going to be delta 2 exponential minus x divided by 1 plus exponential of x divided by delta, which is minus exponential of minus 3x. I'm going to add here over 1 to make again the sandwich rule. Okay, so this is going to be, this here is going to be minus 3x becomes positive. By the way, this minus is going to be outside, minus integral of 3x minus x exponential of 2x divided by 1 plus exponential of x differential of x. Now, what should we do here to solve this integral? Okay, what I'm going to do, what we are going to do is to make a variable change. Variable change. Let's make u equal to exponential of x. So differential of u is exponential of x, differential of x. So I'm going to split this exponential of 2x and 2 exponentials like this. Exponential of x times exponential of x. And here is the differential of u. Differential of u, u 1 over plus u. So if we that variable change, then we are going to get minus the integral of u1 1 plus u differential of u. So what I'm going to do is here, so what I'm going to do is 1 plus u minus 1 differential of u. So I just add 1 and I subtracted minus 1. Why I did that? Because this 1 plus u is the same denominator, so I can split this in 1 plus u divided by 1 plus u and then minus 1 over 1 plus u differential of u. So we have two integrals, but this cancels and becomes 1. So w2 of x is going to be equal to, because that is 1, then the integral of 1 is just u minus the integral of 1 over 1 plus u differential of u. And this is already the natural lorem, so it's going to be u minus the natural lorem of 1 plus u. Now, let's bring back the variable change. U is exponential of x, so is exponential of x minus the natural logicum of 1 plus exponential of x. Now, don't get confused. This natural logicum and this exponential don't cancel because you have 1 plus. Okay? Okay, so now that we found w1 of x and w2 of x, then we can write the particular solution. The particular solution is y1 times w1 times y1. So the first solution was the natural logicum of 1 plus exponential of x times the first solution, and the first solution is exponential minus x plus w2, which is here, exponential of x minus the natural logicum of 1 plus exponential of x times my second solution, and my second solution is exponential of minus 2x. Alright? Alright, now let's write the general solution. The general solution then is the homogeneous plus the particular. So the homogeneous solution is c1 exponential of minus x plus c2 exponential of minus 2x. Alright? Plus the natural logicum of 1 plus x exponential minus x. Now I'm going to make the multiplication here, plus this exponential times exponential minus 2x is going to be the exponential minus x minus the natural logicum of 1 plus exponential of x times exponential minus 2x. I think we can reduce this solution. Well, this is the solution, but I can see that this is repeated here. So there is no need to write two things. So the general solution will be this is eaten by this one, or it is not necessary because this is 1 and this is a constant, so it's just another constant. So it's going to be c1 exponential minus x plus c2 exponential minus 2x, and here we can factorize the natural logicum plus the natural logicum of 1 plus exponential of x times exponential minus x plus exponential minus 2x, and this is more neat or more simple solution. Okay, so this is the method to find the particular solution using the parameter variation method. So we use these formulas and the integrals to get the particular solution. Okay, so I think we covered this part. You can solve the problems of the homework using this method. Next video we are going to cover Euler-Cauchy differential equations.